Welcome back, everyone. In part 1 of this exercise, we set up the foundation of our warehouse order picking model. We created the global tables, built the rack with 24 SKUs, set up initial inventory, added conveyors and operators, and prepared the system for handling customer orders. Now, in this second part, we're going to focus on the real heart of the model, the logic building. This is where we'll bring everything to life. We'll start by generating empty totes that represent customer orders and assigning them the right labels such as box ID and SKUs. Then we'll use a map variable to link each SKU with its corresponding picking station. From there, we'll develop the pick and place activities with object process flows, and later, we'll also handle the replenishment logic for the rack. So let's jump right in and continue building our order picking process model. First, we'll create the empty totes that represent customer orders. In a general process flow, we'll add a scheduled source. We can set its quantity to 1000 or make it dynamically match the number of rows in the order table. For each token it creates, we'll assign labels such as the row number, box ID, and the SKUs for that order. Next, we'll add an assign label activity. Here, our goal is to determine which SKUs should be picked at which stations. To make this correlation, we'll create a new label and use a simple piece of logic to populate it. On the token, we already have an array containing all the SKUs for the current order. In the rack plan table, those SKUs are divided into 6 different sections. To match each SKU to its processing station, we'll use a map variable. A map is essentially an associative array. It lets you store and retrieve values using keys instead of just numeric indexes, similar to a dictionary in Python. We'll then add a for loop that runs through the length of the SKU array, find the decision point, DP, associated with each SKU, and store these as key value pairs in the map. This variable will become our reference for understanding exactly which items need to be picked and placed at each station. Once this is done, we'll create the tote in the queue and copy the box ID and station map labels from the token to the tote. With the order generation part complete, we can now move on to developing the pick and place activity at each station. For this, we'll add an object process flow and attach all 6 decision points to it. Next, add an event-triggered source and set it to listen for the on-arrival event. Update the object reference to current and store the arriving item's reference onto the token. When a tote reaches a station, we'll stop it temporarily. This can be done using custom code by selecting the predefined stop item option from the pick list and updating the item reference. Once the tote is stopped, we'll add a delay activity to simulate scanning the box and set the desired delay time. Next, add an assign label activity to identify all the SKUs for the current station. This step is straightforward because the box already has a station map label. If that map contains the current station reference, return the corresponding value from the map. For the pick and place process, add a run subflow activity with a length equal to the number of SKUs at the station. Assign the SKU labels to the generated child tokens. Since the operator transfers items from the rack one by one, enable the Run Token one at a time option. Retrieve the item from the list by using Pull from List activity. Ensuring the partition ID matches. Then load and unload the item, adding any required loading or unloading delays as needed. Once the pick and place activity is completed at the station, resume the box. That brings us to the end of this part. So far, we've successfully built the order generation logic, assigned SKUs to the correct stations, and developed the pick and place activities at each station. In the next part, we'll take this a step further by implementing rack replenishment. This will make sure the picking stations never run out of stock, keeping the warehouse process realistic and continuous. Make sure to subscribe and hit the notification bell so you don't miss part 3. Until then, happy simulating.